Good afternoon and welcome to this webinar, Sustainable Solutions for Treating High-Strength Wastewater. This event, brought to you by Dairy Foods, is sponsored by Xylem. I'm your moderator, Brian Burke, editor of Dairy Foods. Thanks for joining us. Today's presenter is Jose Molina, Senior Business Development Manager at Xylem. Jose Molina is a business development manager with Xylem Evoqua's ADI systems team. For close to 30 years, Jose has been involved in the design, development, and startup of anaerobic and aerobic treatment systems at multiple locations around the world, treating wastewaters from a variety of industries with particular focus in the food and beverage fields. Don't forget to submit your questions, and later in this program, our presenters will address as many as possible. Today's event is being recorded and archived on www.dairyfoods.com. Okay, and now I'm excited to turn it over to today's presenter, Jose. Go ahead, take it away.
Thank you, Brian, for the introduction. Very kind of you. So I guess this is a topic that might be becoming more and more frequent, is dealing with sustainability. The typical Dairy Foods magazine readership might be more used to talking about sustainability within production. And today it's a little bit of a change in flavors, and we're going to talk about sustainability from the point of view of waste and wastewater, which is kind of like the field that I play in. To start with, I guess we prepared a couple of polling questions. So I'll get you to the audience to give us a quick response here. For the people on the meeting today, if your facility is in need of a temporary or permanent system, you're starting to think about a new and existing treatment system, or just doing your research. So we'll give you 15-20 seconds to give us some comments here. All right, so I see that some people might be already talking or thinking about a permanent or temporary system. And of course, there will be a few of you that are just starting to think about it and having those conversations at your plant. So thank you for that, and we'll be happy to address that for you folks. Oh, there's a result. So I'd say 5 people that are already thinking about it, 8 people are already thinking about it, and then 15 that are just starting to do some research on the topic. Thank you all. All right, so as Brian was saying, I'm a part of the ADI systems team, and together with the Wastewater Technologies, we joined about a year and a half ago onto the larger Xylem team. So Xylem is a worldwide player in the water sector. We have coverage worldwide, as you can see with on the dots on the map. And my work over the years has involved doing a lot of treatment systems in North America, but also it has taken me a little bit on more over the international projects as well. So wherever there is industrial wastewater that needs to be treated, I'd be happy to look at it, and sometimes I get to go to some interesting countries, some interesting sites for sure. I am proud to say that Xylem places a lot of importance on sustainability, and I guess sustainability has been a big part of what I have done over my career, getting close to 30 years now, but who's counting, of course. So our sustainability involves not just doing ourselves the work that is more sustainable, but we're also helping our customers achieve their sustainability objectives. More on Xylem's sustainability policy can be found in our sustainability report. So if you're interested in finding out more about it, I think you can get to it through our website, or you can contact us as well directly, and we can get some comments on how we can help you achieve your own sustainability objectives. Okay, so a brief outline on what we like to cover. As I was saying, looking at waste and wastewater, what are some of the more sustainable ways of dealing with it? Dairy production plant The first thing to do in sustainability is you're trying to get as much of the product turned into as much of your ingredient, which is normally milk, trying to get it to be a final product. But there will always be losses in production, and your first I guess your first exercise would be to try to reduce that loss. That way you're improving your yield in the plant. But there will always be some waste material. And how do you, from a sustainability point of view, how do you recover that value, or how do you reduce your waste? And of course, how do you improve your sustainability score out of your overall production process? So, as you know, the fact that there's growing demand for dairy products, we're talking about an industry that could be in the 600 or 650 billion dollars per year worldwide. That has to do with demand for milk and milk products, and also a growing population and increasing urbanization. People are always demanding better and better products and better nutrition. So the dairy industry has responded in kind, and so we're seeing a trend towards larger production plants. And of course, as you do that, you're always having to look at how do you create those products in the most sustainable way possible. Okay, so what does the wastewater look like in coming out of a dairy plant? What is in that wastewater? As you know, milk comes into the plant, and you're either making fluid milk, you're bottling that milk, but you're cleaning the equipment that you use to do that bottling. But as you get into more of a value-added product, whether it's cheese or yogurt, ice cream, or butter, you will be handling that product that came in, doing something to it, and then trying to get as much of that original milk that came into the plant, trying to get it into a final product. There will always be some losses, and those will end up in your wastewater. In some cases, there will be also bottling and packaging losses as well. In dairy processing, the 3-second rule does not apply. So anything that has been contaminated, anything that has hit the floor, has to be disposed of in a safe manner. Ideally, you dispose of it by getting some value of it, even if it's not making it onto the store or to a restaurant. You're trying to still take advantage of the food value of that product that you lost. So in a lot of cases, what you're doing is using it as cattle feed or a feed for other farms. Of course, where we come in is when some of those products can no longer be recovered directly for their value. What we're going to try to do is try to get some value out of the energy that's still left over in that product. Okay, so this is a typical range of wastewater characteristics that you will see in dairy processing. I would say that this range would be more, I guess, typical of a cheese processing plant, for example, or a yogurt processing plant. Most medium to large size plants would generate wastewater flows in the 50,000 to 500,000 gallons per day. Or if you prefer metric units, it would be 200 to 2,000 cubic meters per day. And it's a fairly high organic strength to that wastewater. So if you're thinking of COD, if that's the term that you're familiar with, chemical oxygen demand, the concentration of wastewater in COD would be in the 4,000 to 12,000 milligrams per liter. So that's fairly high strength wastewater. And in some cases, if you have a plant that creates a waste stream, you could be talking about CODs in the 50,000 milligrams per liter or more. And so proportionately, you will also have a BOD in the 2,500 to 8,000 milligrams per liter range. Suspended solids, fat, oil, and grease, of course, is something that you need to keep in mind, that FOG comes from, whether it's from milk fat, or it can be from some of the other ingredients that you might be adding to your dairy product in order to make the product that you're trying to sell. Um, Milk, as you all know, is a great source of food, of protein. So when you talk about wastewater, that protein will also be in your waste stream. So that shows up as TKN, as total killed on nitrogen in your wastewater. There will be phosphorus, there will be calcium, and all of those parameters are something that you have to keep in mind as you're thinking about how to handle that waste stream in a sustainable fashion. So very high COD loads, organic loads that are needing to be handled. And the objective, of course, is to handle it in a way that is sustainable, that is also economical. A little bit of a perspective for you folks, especially those of you who have to pay a sewer bill that's based on pounds of COD or BUD that goes out to a sewer and for the municipality to treat. Think of it when you see that bill. If you are paying per pound of COD, that pound of COD that's going out in your effluent is equivalent to about 1 gallon of milk that you lost. So it's a gallon of milk that did not make it to the supermarket. It's a gallon of milk that you paid for to come into the plant, and then you're also paying for that gallon of milk to be treated by somebody else. Where we come in, and this is what we're going to talk about today, is how do you, rather than paying the city to treat that waste milk that made it onto your effluent, how do you treat it in a more sustainable way and maybe recover some of that energy that's still present in that wastewater? So what are the conventional ways or the more traditional ways of handling that dairy processing wastewater? Well, one thing to do is to do primary treatment. You try to recover suspended solids and the cream in the wastewater. You recover the FOG, you remove it. And then usually where that wastewater goes is into an aerobic activated sludge process. So that removes the BOD, the nitrogen, the phosphorus. But these treatment methods require a lot of energy. There's an energy input to treating wastewater aerobically. And you're also generating quite a bit of waste sludge. And so that sludge has to be handled, has to be dewatered maybe, and it has to be trucked away and disposed of safely. So that represents a high cost to the operation. And of course, that's a little bit less sustainable in the long term for the plant. So as I made the pitch earlier, we're trying to help you folks meet your sustainability goals. And one way to achieve that is to try to recover the food that's still in the wastewater. Perhaps you can add some dissolved air, and the little bubbles of air in a dissolved air flotation system will bring up those solids to the top. It will bring up the fat, oil, and grease, bring them to the top, and maybe you are able to sell that material and use it as cattle feed. So that's one way of trying to achieve that objective of reducing what goes out to the environment or what goes down to the city for the city to treat. There's some points here about when to use it, when not to use it, advantages and disadvantages of using dissolved air flotation for treating your wastewater. Now, where I get more excited is when you're able to take that high strength material, all that water with a lot of organics in it, a lot of calories still left in that waste stream. Why don't we, rather than discharging it into the environment, why don't we put that material into a anaerobic digester? So in an anaerobic digester, we have specialized bacteria that are able to convert the energy, those calories that are still left in the wastewater, and they're able to convert that into biogas without the need for a high energy input, the need for electrical usage for that treatment. And as the bacteria convert that organic matter into methane and biogas, this can become a source of energy back to production. So again, all that high strength wastewater that you were not able to recover or that you were not able to turned into a final product that can be sold at a supermarket, what we can do, the next best thing to do with it is to turn it into that valuable biogas. Of course, there's a value to experience. So our team has been building these anaerobic reactors for perhaps 40 years. And over the years, we've improved on how to design, how to build those reactors in order to squeeze the most energy out of that waste stream as possible. And the larger the load, the higher the concentration of waste material in your waste stream, the more it makes sense for you to look at anaerobic treatment as a way to handle that waste stream. The biogas will be generated. It's a combination of methane, but also CO2 and traces of hydrogen sulfide. So what we're interested in as a source of renewable energy is that methane, that CH4 that comes in the biogas. Here's a picture of a system where we actually do that. So every pound of COD that you have treated anaerobically and converted to methane will turn to about 5.5 cubic feet of methane. In metric units, 1 kilogram of COD will give you about 0.35 cubic meters of methane that's generated. That is a source of energy. The methane in that biogas has the same heat value as natural gas. So in a lot of cases, we are able to substitute biogas instead of natural gas in something like a process boiler or dryers, or even in electrical generation. A couple of quick case studies. Here's a system in Brazil where it's very large production. It's mostly cheese, but also all other dairy products. A very large organic load that's generated there. 90% of the organic matter in the wastewater is converted to biogas, which is then used back at production and process boilers. Excuse me. The case study a little closer to home. There's a large cheese plant in the Midwest United States. Again, very large load. We're removing roughly 85% of the organic matter in the wastewater, and that biogas as well is being utilized in process boilers in order to reduce the natural gas consumption at the cheese plant. For very large systems, what we like to do when the economics are in our favor is we purify the biogas. We remove the CO2 and hydrogen sulfide and other impurities, and we are able to put that biogas into a pipeline. So there are a lot of incentives right now to be able to do that. So that for the large system, that will have a very large return on investment when you're able to do that. Of course, you've taken the energy out of that wastewater, but you can't ignore that there's still a lot of liquid that you need to dispose of. So depending on how or what objectives you have for discharging that treated wastewater, we can talk about activated sludge system and aerobic treatment system that can then address the nitrogen, the phosphorus, and maybe BOD and TSS objectives that you need for final disposal of that treated wastewater. In some cases, you might be looking to direct discharge that treated wastewater into a river, so you need a higher quality, or you might be looking to use it as irrigation water. So again, different objectives, different quality that you desire will dictate what kind of treatment system you will have for treating that final effluent. In cases where there is where water is more valuable, for example, the Southwest United States, where you have a water scarcity, we will also look from a sustainability point of view. We might want to look at reverse osmosis or other membrane treatment technologies to get you even higher quality water that you can then use as a boiler makeup water or maybe cooling tower water, and again further achieving your sustainability objectives and overall production for your plant. So this is a very brief introduction to some uh, options that you might want to look at for handling those high strength waste streams. I'd be happy to look at a specific opportunity that you might be looking into, and we can get you conceptual solutions that might address your concerns. I'd be happy to answer some questions right off the bat. Thank you very much.
Okay, and it looks like we do have some questions, so we're going to get to that in 1 second. Thank you so much, Jose Molina, for such a great presentation. Before we get to our questions, though, I wanted to make sure that to remind you that we love your feedback in our webinar survey to help improve our programs. Okay, so let's see what we have. We have some questions for you, Jose. Are you ready? I got some stuff. Let's start with, if we generate biogas on site, can we put that energy back into the grid?
Yeah. So that last picture that one of the last few pictures that I showed is a very large system. Yes, you can put that biogas into the grid. There's a bit of work that needs to be done for it to qualify as renewable natural gas. It has to be a fairly high quality. You need to remove the CO2 that's in the biogas. You need to remove H2S and other impurities. So it's a little bit more work that needs to be done, a little bit more capital cost, a little bit more operating cost, but the value you get out of it in terms of incentives, in terms of the actual value of that gas going into the pipeline will make it worthwhile, especially for the larger projects.
Okay, great. Here's another one. We are in the process of designing a permanent system. Do you have rental equipment we could put into place until our permanent system is built? It says DAF mobile, MBBR mobile clarification, and all water movement pumps, pipes.
Yeah. So the large anaerobic reactors that you saw in my examples, those are capital projects. So those take a while to construct and get going. The idea would be that if you're building a large project like that, while that's being built, and you still have quality objectives that you're trying to meet, we can certainly look at providing temporary equipment, whether it's a DAF, a dissolved air flotation system, or some mobile aerobic treatment might solve that problem in the short term to get you to that final permanent treatment system that you might be building. Yes.
Okay. Great. We got a bunch of questions in here, Jose. So let's, I might have to turn it to a lightning round with the last few minutes we have. Do you utilize the same types of systems for large dairy farms that you use for large industrial processing plants?
Oh, that's a very good question. So yeah, I should clarify that most of the systems that I use in my presentation, and I use as examples, those are dairy processing plants. Those are plants that make either fluid milk or cheese, yogurt, things like that. The dairy farm itself is a slightly different material that you're trying to handle. As you know, in a dairy farm, you'll have manure will be a more significant component of that waste stream. There will be also milk losses, of course, and all other processes, but the manure makes it a little bit more challenging. So it will be a different solution that would have to be applied at the farm than at the processing plant itself. Yes.
Okay, great. Next one is, what is the lowest flow rate for this air process?
The air process, you mean I'm going to assume that they meant the dissolved air flotation system. So those can be quite small. So even for very small processing plants, a dissolved air flotation system will be applicable. So I would say as little as 2,000 gallons per day. I'm sure you can find a unit that's sized properly for such small flows. As I like to say, we do a lot of large systems, but we're not afraid of small either. You just have to apply the right technology, the right size equipment for those smaller units.
Of course, of course. Sorry, I'm running through them because we have a bunch more. Could the DAF sludge be processed through an AD plant rather than recovered for stock food?
Yes, indeed. Yeah. So in a lot of the cases, a lot of the systems that we have built, we skip the DAF and we treated the raw wastewater straight up. But there is an argument to be made that you use the DAF, you concentrate some of that non-soluble material, whether it's solid or fat oil and grease, and then you can design an anaerobic digester for just treating that stream. So it's a slightly different design, but yes, that's something that we can look at for sure.
Okay. Any idea as to the NPK fertilizer value of the anaerobic sludge from the BVF?
Oh, okay. This is somebody who's familiar with our BVF reactor. So normally, what you have, I don't have the numbers straight out, but the nitrogen or phosphorus concentrations of the sludge are in the, let's say, 8% by weight, dry weight is nitrogen, and about 2 to 3% would be phosphorus. So the phosphorus will be a little higher, a little lower, depending on how much of it comes out of solution in an anaerobic reactor. But yeah, it would be typically in the 3% of the 3% solids of that sludge stream. Yes.
Okay, I think we only have time for a couple more, but just reminding everyone that Jose Molina's information is right here on the screen. If you do need if we can't get to your question, please make sure that you contact him. He'll be happy to answer that way. Here's the next question. Is there a limit on moisture content for sending to an anaerobic treatment? Are there any other limitations for sending to anaerobic digester?
Okay, so this is an interesting question. Generally speaking, the more concentrated, the better, because you're handling less volume. To the point where maybe you have the solid concentration might be too high, and then we have to design accordingly. Yeah, no, I don't think there is a limit. You should need for it to be able to flow, right? So enough water for it to be digested as a liquid rather than digested as a solid.
Okay. Okay, great.
I think that's an interesting question. I would have to look at the specifics of the question in order to get into more detail on it. Very, very interesting.
Okay, question. So if the person who asked that question could please contact Jose directly on the information on your screen, please. I'm sure he'll be happy to respond to you that way. Okay, I'm gonna get them by the what we received at the time we received them. So. Here's the last one for today. Besides the DAF, is there any other option for fluent pretreatment other than biological systems?
Okay. So DAF is an easy and elegant way to remove the non-soluble material. You could do the same thing using gravity. That gets a little complicated, right? Because fat oil and grease will want to go to the top, suspended solids will want to go down to the bottom. So you might have to use some kind of gravity clarifier to do that pre-treatment. The dairy industry is very good at using membranes and centrifugation to separate out the different components of milk. So yes, I think we could look at doing something like that as well. So the more moving parts, maybe it's a little bit higher operating cost, but yeah, you would be more efficient at separating the wastewater into its different components.
Okay. Well, thank you so much. Unfortunately, that's all the time we have for questions today. Please join me in thanking Jose Molina for his presentation, as well as our sponsor, Xylem. If you have any additional questions or comments, please don't hesitate to click the Email Us button on the console. Please visit www.dairyfoods.com for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you have found this webinar to be a valuable experience. Thank you.